Hey everybody, Mr. Forden here. Thank you for tuning in for another geometry video. Now, I just got this email here a few hours ago from a student, 5 hours ago to be specific, asking, hello, can you send me a video explaining how to do 933? Thanks. 933 number 2. So maybe my guess here in this one is that they weren't sure about this part here, which was asking about the trapezoid. BDEC. I can go over that one. I'll just go over the whole thing, question 933. And this problem was actually on the homework that's not due on Monday. It was due on Friday, but I sent out the answer key, and maybe the answer key wasn't enough. And part of the reason why the answer key was not enough, oops, disappeared there, is that the answer key was actually incorrect on this one. Oh, no, shucks, I made a mistake here. I misread the problem, so I'm just going to do it all from the beginning here. I just kind of misread it, so it's first going through it. Okay, so let's check this one out here. In this diagram below here, segment DE is a mid-segment of triangle ABC. That's the large triangle here, ABC. So we know that DE is a mid-segment, so we know that it's we got a midpoint here and a midpoint there. Sorry, a midpoint for D, so AD equals DB, and we also know that E is a midpoint. AE equals EC by definition of midsegment. But there was also a theorem. Okay, the key thing here is the theorem from one of the earlier chapters here, that a midsegment here, DE, is half as long as the side of the triangle that it doesn't intersect. Okay, so a midsegment intersects two sides at their midpoints, and what it happens to be is it happens to be half the length. So if I made this X, half the length as the third side of this triangle that it doesn't intersect. So this would be 2x. So what I'm trying to show you is here that DE to BC would be in a 1:2 ratio. And that's important here because we also have some similar triangles that get formed. Triangles ADE and triangle ABC would be similar by the SAS SAS similarity postulate. Okay, so SAS similarity postulate. Like angle A is congruent to itself, and we know that DAE, that triangle, and BAC, they are similar because their side lengths would be in proportion as well. Okay, because remember, point D is a midpoint, so I know that AD is half the length of AB by the midpoint theorem. I also know that AE is half the length of AC by the midpoint theorem. So I could have proven that this top triangle here is similar to the larger triangle down here, and they're in a 1:2 linear scale factor ratio. Okay, so this problem here is a little bit more evolved beyond like what is the scale factor of the problem. It's talking about area. If the area of triangle ABC is 96 square units, what is the area of triangle ADE? So when I was doing the answer key, preparing it really quickly, oops, I'm like shiny over here, preparing it really quickly before class the other day, I misread this problem. I read this as the smaller triangle ADE is 96, and I thought I had to find what is the area of the larger triangle. Oh, okay, the reverse here. I didn't actually look at the actual vertices here. I was just going too fast and making mistakes, and that's fine if we go too fast sometimes with homework. We got nothing to lose that one. We're just practicing. Okay, so anyways, ABC is the large guy here. AD is the smaller guy. And I know that my scale factor from my large guy, right, BC to DE would be 2:1. My area scale factor would be the square of that, okay? So what's 2 squared? 4, right? So the larger triangle's area is 4 times larger than the smaller triangle's area, ADE. That's what we need to figure out. So, just to sort of summarize this, right, linear scale factor of similar triangles, well, it equals 1:2. Therefore, the area scale factor, and they give us the large one area is here is 96. The linear scale factor, the area scale factor is right. It's going to be the square of that. Because remember, square is 1/2. The area is 1/2 base times by height. That's 2 dimensions. It changes by a factor of 2. So really, it's changing by a factor of 4 as we go small to large. Okay, so I have a 1:4 scale factor. So the way that I solve this problem for at least getting to the area of triangle ADE is, well, triangle ADE is the small guy there. So area of triangle ADE is going to be in a 1:4 ratio with the area of triangle ABC. So I can put what the area of triangle ABC represents down here, which is 96, and I can go ahead and solve this. It's just gonna, I just take 96 divided by 4, I get my answer. I could also cross multiply. I would get 4 times the area of ADE, and cross multiply there would equal 96. Okay, divide by 4. So obviously area of triangle ADE would have to equal 1/4 of this 96, which is 24 square units. So that is my first answer here for this guy. Okay, so I don't know if you were asking about that problem, because it says here, oh, this was on homework number 2. Okay, so that's what you're doing here. So maybe you weren't sure about that. The harder thing, I think, for more people in this class is actually the second thing, which is asking about the trapezoid here. Okay, so if they just list 4 vertices, they're talking about a quadrilateral. They don't say like just find a polygon there that has 4 vertices. Well, that's gonna have to be a quadrilateral, the way we have it here. So we want to find an area of triangle BDC. Well, we can get there because of the area addition postulate. That's how we can get there. Area addition postulate. Okay, why can we get there here? What did I just figure out about area of triangle ADE? Well, this here has an area of 24. What did I know at the beginning of the problem here? Okay, what did I know at the beginning of the problem here? The whole darn thing, the whole figure here had an area of 96. So how can I isolate what that trapezoidal area is here? I know what you're thinking. You're like, well, I don't have the base length and the bases and then the height running between them. Well, no, I don't. So I can't actually use the formula. So if I can't use the formula, really the only other way I can do it is, well, if I can find some other shapes I can cut around that trapezoid and figure out their areas. Well, I can't do that here. The only other way is going to be the area addition postulate. Okay, so if I know that I have up top here in green, which is the 24, okay, and if I have the whole thing, okay, the whole thing here is 96, well then this piece here, this trapezoid down here, is just going to be the whole thing, which is 96, and we're going to take away that part in green. We're going to take away 24 from it, okay? So I'm going to do 96 minus 24, and that's going to equal 72. And that is my answer for trapezoid BDEC. Another way to think about it is that this isn't a 1:4 ratio right here. Okay, so this is one part of the 4 parts. So down here below here, this would have to represent 3/4 of the remaining 3, but the remaining 75% of this area. And 3/4 of 96 would be 72. This would actually be in a 1:3 ratio here, because 1 part's 3 parts, 4 parts 1:3 ratio, 3:4 ratio, 3:1 ratio. Anyways, hopefully you get it here. Thank you for asking the questions here. Of course, let them go. If you haven't noticed, I like answering questions like these. I like talking about the math. So send me an email if you have any questions. Okay, thanks guys. Bye.